6th. We only got a couple weeks till what, Thanksgiving, I think. Does that sound right? Thanksgiving break is on the 22nd. We have 2 full weeks here and then 2 days. We'll call this a Unit 1 DA review. So the very first questions, the first 3 are multiple choice, which I know is totally new, but we're supposed to put a mixture of multiple choice and extended response questions on our district assessments. So we decided, well, let's make these district assessments or these first 3 multiple choices. So I'm not going to give you obviously the exact questions. Sorry, I have to say that out loud, but I'm going to give you questions that are very, very similar. So on question 1 on the DA, you're going to be faced with an equation like 2/3 of x equals 8. And you're going to be asked, what is the solution? And it's not, I mean, you still show work and everything, but you just pick from multiple choice, which I know I never do multiple choice on my regular quizzes, like never. So what would we do to both sides? Yeah, you can just multiply by 3. If you want to make it just a little bit easier, you could multiply by the reciprocal, but honestly, I'm to the point where I feel like, let's just do it in 2 steps. If we multiply both sides by 3, we get 2x, right? Equals 3 times 8 is 24, and then we divide by 2, and then you just pick the one that matches, right? And I guess you're good on that. Okay, the second question is going to be an inequality, something kind of like this. What would you do to both sides? Divide by -4. And I'm going to show a little bit of work on this one just to make sure that we all catch. This problem was written for one very particular purpose, and it's right now. You do switch the sign. And I would be honored if all 73 of my algebra students remembered that. That'd be rad. Remember, when you divide by a negative or multiply by a negative, you switch the sign. So we're going to switch this to is less than or equal to -8. Now, this one is a little bit different. It's going to say, which of the following is not a solution? Not. It's in capital letters just to help you remember. So you're going to look for a number that is not a solution. So let's say we had solutions like -10, -7, -12, and -50. Which of those would you say does not fit? -7 clearly does not fit because -7 is not less than or equal to -8, right? -7 is bigger than -8. So be careful in this problem. It's one of those mean ones where you're actually picking not a right answer, but you're purposely going to pick a wrong answer. And there will only be one. So like in this case, I would choose option B because -7 does not make the final statements like cut. Does that make sense? Okay, so you solve it like normal, and then just go find the one that doesn't work. Okay. This next one is a little bit different. And what it is something that we don't do a lot of, but it's still on here because it's, I don't know, it found its way on. We just dug it out. Have you guys ever done indirect measurement before? So let's say that I'm 6 feet tall. And let's say that I'm standing outside one day and the sun is casting down a shadow and it's casting a 4-foot shadow. Now I'm standing next to, say, a tree, and I'm wondering, man, how tall is that tree? So what I can do is I can use proportions to figure out how tall the tree is. It's a really cool way to measure things in life when you can't actually measure them. Like you can't realistically, most of us, climb to the top of a tree and then have your buddy extend a tape measure up to you and say, oh, I got it, man, it's 32 feet up here, woo! You know, that's not realistically how we do things like that. And so what we do instead is we measure it indirectly. I'll show you what this looks like. This is going to be one of the ones that's maybe a little bit confusing for you. So if I'm 6 feet tall and I'm casting a 4-foot shadow, let's say I'm standing next to a tree and the tree is casting a 20-foot shadow. Now, you would agree that that's something that I can measure, bless you, because it's on the ground, right? I could go to the base of the tree and I could extend a tape measure and I could actually see that the shadow is 20 feet tall. So the question becomes, well, how tall is the tree? Well, to do that, we just set up a proportion, and it goes like this. We say my height is to the height of my shadow as the tree's height is to the length of the tree's shadow. If you were to do it with pictures, it would look like this. Like, here's my shadow and here's me, right? And then here's the tree's shadow and here's the tree. So in geometry, you'll learn more about these. These are called similar triangles because the sun's angle is going to cast down at the same angle over the top of a tree as it is over the top of my melon. And so what happens is the sun's rays come down and they cast the shadow here, and then they cast the shadow here. And it's a fact that these triangles are just like each other. They're what we call proportional, similar triangles. And so I could say I am 6 feet tall. My shadow is 4 feet long. The tree is X feet tall, and the tree's shadow is 20 feet long. We will. So we're going to take this in this red box over here, and we're going to put numbers in place of all those words. And it actually turns out to be such a simple problem. So if I go and put my height right here, I put 6. And if I put my shadow underneath that, I put 4, right? And then I go to the other side, and I'm only going to know one of these two things. And obviously, I don't know the tree's height. That's the whole point of the problem. But I do know that the tree's shadow is 20 feet long. So I can put 20 for the tree's shadow, and then I can put X for the tree's height. And you know how to solve these because we just talked about them on the last quiz. So all you do is you cross multiply. So if I cross multiply this way, what do I get? And if I cross multiply this way, what do I get? And then I set those equal, I divide by 4, and I get X equals 30. Therefore, the tree is 30 feet tall. Good application of simple algebra. It's called, again, indirect measurement. If you have something, you could even do it for a building that's like 400 feet tall. Like if you really wanted to, you could very quickly measure yourself, measure your own shadow, and then take a little time, but you'd want to be fast because the sun moves, right? And then you'd want to measure the building shadow and then just set up a basic math problem like this. Got it? Now, the thing I want to say about this problem, I don't think that's difficult at all, is you're going to have to use decimals. So let's say that something was 4 feet, 6 inches. What would that be as a decimal? Like if I just wanted how many feet that is, what would you guys say that is? 4.5. Very good. So this would be 4.5 feet. And I want to let that simmer there for a second and see if you guys agree or disagree. Does anyone have any issues with the fact that 6 inches is half of a foot? I will tell you, you might say, well, why are we talking about this? Because having given this assessment before, if there are some people who really, when they say 4 feet 6 inches, they put 4.6. And that's really, really bad because there are not 10 inches in a foot, right? So inches don't convert directly to decimals. You have to think about inches as out of 12 and then ask yourself, okay, so 6 out of 12 is a half of a foot. So 0.5. Do we agree? Okay. And then you could use a calculator for that. And honestly, you don't even have to solve this one. It just says which proportion matches. So in fact, with this problem, you could have stopped right here and just picked the answer that matches correctly with the proportion. Any questions so far? Okay, so that's the whole first page. The second page contains a whole bunch of equations, and I'll just kind of show you a sampling of how simple they are. So they are, I'll just run through a bunch of them. Let's say you had like 6K equals negative 42. What would you do? Divide by 6, you get K equals negative 7. Yeah. What if I gave you something like M over negative 4 equals 10? What would you do to both sides? Yeah, and you'd get M equals negative 40, right? If anyone needs me to explain something, you got to advocate for yourself and just ask, okay? What if I gave you something like m minus 3/4 equals 2/3? How would you solve that? Yeah, you could. Let's take our fraction killing. I mean, if you know how to use the fraction button on your calculator and you're comfortable, you could just add 3/4 to both sides, right? If that's your thing. But the safer route, like why I teach you fraction killing, is for moments just like this. I could multiply by 12, like Morgan said, and then I just multiply here, and I get 12m, and then I multiply here, use the hook. What do you get? It's a 3. 12 divided by 4 is 3. 3 times 3 is 9. Good job. Equals, and then do the hook again on this last part. 12 divided by 3 is 4, times 2 is 8. And then from here, you would add 9 to both sides. And then you would divide by 12, and you'd get m equals 17 over 12. Like, I feel like that's light work for you guys. I don't think that's nothing, right? Okay. How about something like this? X plus 11 over negative 3 equals 6. What would you do first? You would multiply by negative 3. Very good, 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 good. So what would we get? Nice job. Right? Subtract 11, you get x equals negative 29. Simple pimple. These aren't hard, are they? I don't think. I mean, they might have been hard like on September 3rd or something for some of us, but it's like, this is old hat for us. How about something like this? That's a plus sign, by the way. I'm going to fix that. I don't know what happened to my, it just kind of, it lags a little bit sometimes and catches and connects things that shouldn't be connected. About this. Yeah, you guys are answering questions well. Combine these like terms. And remember, because they're on the same side, you just literally combine them. What's negative 5x plus 2x? Negative 3x. And while we're here, why don't we go ahead and subtract that 10 to the other side? What do we get over there? Negative 25. And then we would divide by negative 3 and get x equals 25/3. Still good? Okay. I'll switch colors so you can kind of see what I'm doing. What if I gave you this? Purple equation, what would we do? Cross multiply, very good. So if I go this way, what do I get? And if I go this way, what do I get? 9 times 24 is 180 plus 32, so 212. And then divide both sides by 8, and you get x equals... Wait, 9 times 24 is not 212. It's 180 plus 36. That's 216. And then you divide, my bad. Oops. And then you divide and you should get, what's that going to be? 27. Okay. Any issues? The one that looks the hardest on here, I hope I've done my job and you've done your job so that what should look difficult for some kids is you're just look at it and go, this is easy. So let's say we had like 2 times x plus 3 plus 3x equals 3 times 5 plus x plus 6. I mean, there was a point in your life, honestly, like 2 months ago, where you might have looked at that and said, oh, we're not scared. What do we do? Distribute, right? We're not going anywhere until everyone's free to move about the cabin, right? So don't even go thinking about moving things around. No one's moving yet. So we take the 2, shoot it through. What do we get? Plus, good. And then copy down the plus 3x. And then on the right side, shoot the 3 through. What do we get? Plus, nice. Yeah, and then everyone is now free to move about the cabin. And the only interference I would run here is to tell you, don't start moving things to the other side, right? It's one of my main missions for semester 1 every year is to get you guys to not think about green lighting yourself yet. You need to take this 2x and this plus 3x and combine them first. Remember, we treat each side of the problem as our priority. And then on the right-hand side, I see a 15 and a 6, which make 21. And then what would we do from here? Right, you guys got it. So basically, I take the purple egg, shoot it to the left. I take the red egg, shoot it to the right. And that's just subtracting. And if you want to show lots of work, you're welcome to. But as I've said for months, like a month and a half now, we're kind of past that point. And so you can do it as quickly as you want. I wind up bottom line with 2x over here and 15 over here, right? And then I divide by 2 and I get x equals 15 halves. Still good? There's one problem on this page that concerns me, and I'm going to show you what it is. And it's funny because it doesn't look like a difficult problem, but let's see how you handle this. Let's say we had 10 minus m equals -3. It doesn't look difficult at all. It's like it's a little cute, fluffy kitten, and you go to pet it, and then it bites you. And you're like, what? What is this? Have some respect for this problem, and the reason is because of this right here. Yeah, there's a couple routes we can take. Route number 1 is what Gage said. I could just go ahead and do -10 on both sides. Make sure you don't add 10. I mean, that would be crazy, right? Because that's a positive 10. So if I take away the 10, what am I left with on this left side? Right, and that's where the respect comes in, is don't you dare put m, because that minus sign is still hanging around, right? So we have -m equals what? -13, and we're not done. What do we do to finish? Divide by a negative, so we wind up with m equals +13. So that's the one for me every year that kind of gets a little bit of extra attention because that minus on the variable is a. So that's it for the whole second page. You guys have any questions on that? All right. There are a couple of literal equations on there, and I kind of copied them onto your last quiz. And the good news is you guys, almost everybody, you crushed it. So these two aren't going to be difficult for you at all. Again, I'm going to give you sort of mock-up versions of what they are, just so you know exactly where we're headed with this. So let's say we had like m equals 1/8 times k plus r plus j. And I want you to solve for, well, let's go j. What is non-negotiably step 1? Yeah, let's fraction kill first. If I don't want to get them out yet because I would be getting them out with a fraction. And if I shoot that fraction through, I just take I take one fraction and make it 3. And I don't want to do that. So I'm going to get in the way first. I'm going to multiply by 8. So when I multiply here, what do I get? And then when I multiply here, yellow arrow is important. What do I get? I get 1, I cancel. And so I basically wind up with a 1 that serves no purpose. So I can just put k plus r plus j because the parentheses are no longer needed. And if I want to get j by itself, what do? Just minus k and minus r. Or just, I mean, again, the language for you can be just move them to the other side. I'm really trying to get you guys to start thinking that way. Quit making everything so mathy. Just move it to the other side. So you wind up with j equals 8m minus k minus r. Done. Right? It's done. We got j by itself, so we're done. Game over. Yeah. And then there's one other literal equation, and you'll recognize this again from the last quiz. Let's say it's a w equals m b c over 324. And we want to know what to solve for. So let's go ahead and solve for m. Yeah, again, regardless of what it is we're trying to solve for. I don't care if someone told me to solve for m or b or c. It doesn't matter. My first step doesn't care. I'm still going to multiply by 324. Because what that does, of course, over here is it takes the 324s and it knocks them out. What do we wind up with over here on the left? And what do we wind up with over here on the right? And at this point in time, you can solve for whatever you want. If we're solving for m, who do we have to get rid of? Yeah, so we just wind up with m equals 324 w's divided by bc. Done, right? So there are two literal equations. That's what they look like. So if you have any questions on either of those formats, make sure you let me know. But I say I put those on as the last two on the quiz, and not everybody, but just most of us, like 90% of us, I think, crushed those two. So I felt like you're going to be good there. All right. And there's a page of inequalities. And I'll run through a handful of these with you. And then there's a couple of word problems that I want to run through with you, because I know that word problems can be a little bit scary, but you guys are so rad and awesome that you're going to do. These aren't really hard word problems. We did a unit on word problems last year. They were like, Marvin is 6 years younger than Alicia. In 15 years, Marvin's age will be 1/3 of twice what Alicia's age will be then. It's hard. And we're not going to do that right now in Unit 1. We might come back to that. But for now, these word problems that we're going to talk about here in about 10 minutes, they're really, really easy. So you'll be fine. But anyways, this whole page right here, this is page 4, I think, of the assessment, is just all inequalities. And again, I say, based on what you've learned with me, I don't think anything on this page will be like hard. It's basic stuff. So first one is going to look something like 3x minus 8 is greater than 4x minus 5x minus 12. So we've entered the land of inequalities now. This whole page is greater thans and less than. So yes, we're still using our fundamental mechanics of combining terms, moving things over, dividing. We just have the extra consideration at the end of, do I have to switch my signs? Do I have to move my variable to the left? And then, of course, at the end, I also have to graph them on a number line. So they're like equations on steroids, right? It's okay. What would you do first? Yeah, if you don't combine these like terms, then you and I are friends off, right? Like that's a non-negotiable. We always simplify the sides first. And so over here on the left, I still have 3x minus 8. But then over here on the right, what's 4x's minus 5x's? It is not x. And that's how quickly things go downhill. It is negative x minus 12. And it's those things that we used to think were little things that really become the difference between getting an A and getting a C in algebra. Like, they got to be tight. So now that we've got the left and the right, the best, cleanest versions of themselves, what would we do? I know what I would do. Hagen, you agree with that? A pro tip here, I'm not going to pause the recording to say this. If you grab the pencil and start writing, there's a few things that will happen. A, class will go a lot faster. B, you'll stay awake. And C, you'll have a good thing of notes to study for the assessment. And that's a win-win-win as far as I'm concerned. If you sleep, you're going to lose out on all those things. We're all tired, but it's Monday morning. Every one of us. Anyone else in here not tired? You feel wide awake? Good job, man. I do not. So you got to stay awake. And this is going to lead to trouble too. You got to force the neck muscles to be engaged. Just not trying to micromanage, just trying to help you. But I hope we all agree that we probably want our variables on the left with inequalities, right? So I'm going to take negative x and I'm going to move him to the other side by adding him. And he's going to say, hey, look at us. We made 4 x's. But if they go over there, then green egg says, well, I guess I will get out of your way and go this way. And the only way green egg can move is by adding himself, right? So the sign stays the same. What's negative 12 on this right side plus 8? It is negative 4, right? Negative 12 plus 8 is negative 4. And now we're going to divide both sides by 4. Are we going to switch our sign? No, because even though there's a negative in the problem, it's not what we're dividing by. So we're going to get x is still greater than negative 1. And I'm not going to graph every one on this review. I just thought, let's run through a quick review of how to graph these. So there are no number lines prepared for you. You'll have to just draw them yourselves. So remember, we sketch a little line. It doesn't have to be beautiful. And we only need to put one number on the number line, and that is -1. And then we make a circle on the number line. And we do not color it in this case. That's something you could put on your page of notes, is just remember, if it doesn't have the equals with it, then we don't color in the circle. And where are the numbers that are greater than -1? To the right. And so again, if you could just right there on the line, just have at it, done. Good. All right, let's run through a couple more of these. What if I gave you 12 is greater than or equal to -5m minus 3? Try to stay awake, everybody. And by try to stay awake, I mean stay awake, or I'm going to say mean things to you. So that's my nice way of saying that. What do we do? What would you do? You could add the 3, sure. Yeah, so let's take the 3 and scoot it to the other side. What do we get on the left if we do that? You get 15. Very good. And what do we do next? We divide both sides by -5. I will tell you this, and because you're a teenager, you probably won't trust me, because that's how, adults say you should do this, and kids go, I don't have to do that. So go ahead, roll the dice, but I'm telling you, you should not do two things at once. There are two problems with this problem. Number one is that I'm about to divide by a negative. Number two is that I got to switch the sides. Do not try to do them at the same time. That is not a challenge. That is an adult who cares about you issuing some advice. You should take it. You can prove, go ahead, do it the other way and get it right. I mean, but I wouldn't. So when I divide by -5, I'm going to temporarily be content with the fact that my variable's on the ghetto side. It's okay. We'll fix it. But what do we do to our inequality? We have to switch it. And then 15 divided by -5 is -3. And now that I can see the solution, I'm now going to green light myself to reverse it. Don't try to do those both at the same time. It hurts the brain. So I'm going to wind up with m is greater than or equal to -3. So let's graph one more, and then after this, I won't graph anymore. I mean, you'll have... It is, good, and that's why I wanted to do this graph with you. This is a filled-in circle. So we're going to go to -3, and we're going to make a circle, and we are going to fill it in. Proves exactly, because it's got the equals with it. So remember, if it's got the equals down here, or equal to, then we color in the circle. That's the key. And which way will I shade? To the right. Yep. So that whole page is really just a bunch of inequalities. Remember, you treat them just like equations. Let's do like one more, and then I want to make sure I have a little bit of time to go through the word problems with you. So there's 6 of those, but we don't need to go over all 6. If you can solve equations, you can solve inequalities. Let's say I had 11 plus x over -4 is less than 8. What would you do first? You could. I'm not going to. What else could we do first? Let's go ahead and move the 11 first in this case, because it'll wind up being, it's not wrong if you multiply, but I want to multiply by less stuff if I can. So I'm going to move the 11. I'm going to say positive 11, make like a banana and split. Get over there to the other side. So I subtract him to make him go over there, and I'm left with x over -4 is less than what? 8 minus 11 is definitely -3. And now I'm going to multiply by -3. So remember what we said is that if you divide by a negative, you switch the sign. But also, if you multiply by a negative, you switch the sign. So my -4s are going to cancel over here. And I'm going to wind up with x is greater than 12. Good. You guys have any questions on that? Okay. So I'm going to actually go back a page. There was one that I skipped. And for this one, I'm going to I'm going to type. So you'll have to, I'll give you a moment to write because something like this I would prefer just to type. It's still not writing. That's, yeah, I guess you could go home and rewatch the video and write later, but you don't write it down, you're going to be the kid that makes everyone else wait while you say, wait, wait, scroll back up. So I realized I had an advantage. I had a keyboard and you have a pencil. So I'll give you a moment to copy this down. And again, you're welcome to go back, like I said, and just watch the video again. Fast forward to this part and let me see if I have any typos. It's fine. By the way, $42 an hour for a plumber is not accurate. They're going to charge you way more than that. I'm sure you guys, if you have any relatives that do any plumbing work, they charge much more than that per hour. Usually it's the other way around. The materials would only cost probably like 36 bucks. They're going to charge you like 150 bucks an hour. Just FYI. Maybe not that much, but a lot. Everybody got it written down? Okay. Your problem on the test is just like this, only instead of a plumber, it's a landscaping person, but the same idea applies. There are two main costs associated with any job. There's, if you have anyone that does anything, or if you have a job like this, you know that the two things we talk about, you'll hear it in your adult life, are parts and labor. You take your car into a shop, they're going to give you a bill and it's going to include parts and labor, parts and labor. That's how every service industry works, parts and labor. So the parts are non-negotiable. Like if you get something put in your car, they're going to like, well, the part itself costs $362. That's solid, like boom. The labor is how much they have to pay, how much you have to pay for the work that someone or people, one or two people put in on your car, right? You got to pay their bills too. So we're going to write an equation. So step one on this, and I'm going to underline this. It's underlined on the test, but I just have to say, if you don't follow the directions, I can't give you credit. And that might be frustrating because some of you already know the algorithm. Like you get the algorithm as well, duh, I just take 450 minus 200 and divide by 42. Don't think I don't know that. You're not like pulling one fast by, ooh, look at how sneaky. The directions, and I'm going to underline this for you, say to write and solve an algebraic equation. If you do not do that, we won't even grade this. Is that clear? Okay. What does it mean when it says an algebraic equation? What does the equation have to have? An x. Very good. And so I'm going to write an equation and you tell me if it feels okay. Would you guys like to help me write the equation? Here's how the equation goes. Basically, we agree, all of us, that parts plus labor are going to equal the bill, right? The money's going somewhere. It's either going to parts or it's going to labor. So let's think about this for a second. How much did I spend on parts? So I can put $200 in place of parts. How much did I spend on labor? And don't say $42 because there's more to it than that. How much? 42x, right. I spent $42, but it's times the number of hours that the plumber had to work. And so the labor portion of my equation is going to be 42x because I don't know what x is. Maybe he or she worked for 3.5 hours. I don't know what it was, right? And then finally, it equals the total bill, and the total bill is $450. So as I said before, if you think ahead of time that couldn't I just not write this equation, you're just not listening. This equation is the meat and potatoes of this problem. Are we clear? As I said a minute and 36 seconds ago, yes, in the beginning, you could have just looked at the problem and said, oh, it's easy. It's 450 minus 200, and then I divide by 42. Don't think we don't understand that. We clear? This equation, who's listening, this equation is mandatory. Now, from here, Cruz, absolutely, we would subtract 200 from both sides of our cute little equation, right? And we would wind up with 42x equals 250. And what I'm about to do now is calculate the number of hours that the plumber had to work for. So this would be a good time to grab a calculator. This is not an appropriate time to think improper. This is one of those real life scenarios where putting a fraction like, oh, 17 thirds, like who talks like that in the business world, right? Like we want decimals and things like that. So I'm going to take 250 and I'm going to divide it by 42 and I'm going to round up a little bit. Technically, the answer, and by the way, the answer on the test will come out nice. Mine, I just made it up, so it was a little ugly. But the answer comes out, in my case, to be 5.952380952. So for our intents and purposes, can we agree that the plumber worked for around 6 hours? Okay, good. And again, the one on the test was actually written and thought out. Mine was just, I just pulled it out of thin air. So that's why we got a really ugly number here. But so that would make sense, about 6 hours. So if you took 6 hours times the $42 per hour, and then you added that to the 200 for parts, there's where the bill comes from for 450. You guys have any questions on that one? The most common mistake that I see, having done this for a very, 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 very long time, is that people not they don't like, but they tend to get these two numbers mixed up. And if someone wrote this equation over here, I'm not going to make fun of those people. I'm just going to ask you, what would they be saying if they did that? How much would the labor be in my white equation? $200 an hour, with the parts being only $42. So make sure you give respect to the idea that the labor is the one that gets multiplied by X, because that's the one that changes with every hour. So the variable one goes with what varies the time. Got it? So don't do that. Those two things I put in yellow boxes, make sure you give them some love. Make sure you put them in the right place. Attach the labor or the hourly one to the X. Got it? Okay. Any questions on something like that? All right. Again, please, my heart breaks for you if you just try to out wise guy somebody and just dive in. It's like if you just give the answer, you're not going to grade it. Minus whatever, 10 points, minus 10. So what we want to see in that problem is that you can structurally create an equation from a word problem and then solve it, of course. Solving is easy. Okay. All right, that covers everything except for the back page. And on the back page, again, I'm going to write you a similar situation. I might be getting a little bit too close, but I don't really care. So let's do this. And again, I'm going to type. So try to start writing as soon as I start typing so that you can stay caught up. So as you're writing, I know that's a lot to ask of you, but again, you can go back later and fill in the blanks here. I'll post this up as soon as we're done here. The idea is your bank says if you go below $10, we're going to assess you like a service fee or something like that. I don't actually know that that's realistic, but I know that banks do assess fees for various odd things. So pay attention when you get your first bank. Make sure they don't have a bunch of weird stuff. And if they do, say, yeah, banks want your money. So you can just walk out and say, no, thanks. I'll go to the other guys across the street. Banks really want your money. So sometimes they'll waive things. But let's say you did happen to make a mistake and you joined this bank and they say, okay, if your account drops to $9.99, we're going to hit you with a $30 service fee or something like that. So right now I have 485 bucks. And what I'm going to do is just every week, maybe for gas, I'm going to go down and I'm going to pull out 20 bucks. Next week, pull out 20 bucks. Next week, pull out 20 bucks. So part A, everybody okay on the situation? Okay, part A, there are three parts to this. It's a three-part question. So part A will have us write and solve an algebraic for this. So basically, I'm answering the question that I asked up here. How many weeks can I keep drawing $20, withdrawing $20 without, this is important, without going below the $10 cutoff line? And again, please, if you think, can't I just do this without the equation? The answer again is no. These questions aren't so much about your ability to do basic math as they are your ability to construct a math problem using X. Okay? So when we write the inequality, it's basically going to go like this. What I have minus what I withdraw has to stay greater than or equal to 10. Notice it says in the problem it can be or equal to because it has to be at least $10. And at least always means that it can equal that $10. So we all agree with the situation. What I have minus what I take has to stay at or above 10. So what do I currently have in my bank account? So I'm going to change what I have into 485. Now, this is that thing like with the labor problem and the plumber problem just now. This is that same idea. How much am I going to withdraw? 20x, right? Because it's $20, but I do it every single week, and X is the number of weeks. So like if I did it for 1 week, I take out 20. If I did it for 5 weeks, I take out 20 times 5 times, right? And this is the math problem that presents itself to me. Again, what you have minus what you withdraw has to stay at or above a certain cutoff point. Any questions about that? Okay. And then, of course, comes what for us by mid-November should be the easy part, and that is the math. The math is generally pretty straightforward. How would you solve this equation or this inequality, excuse me? Subtract the 485. And we get negative 20x is still greater than or equal to what? 470. Nice job. And then grab your calculator. And I'm not even going to type in the negatives because, like, by the way, do I switch my sign? Yeah. I do, right? X is less than or equal to. And so I'm just gonna type in positive numbers because the negative divided by negative is going to be positive anyway. So 475 divided by 20 is 23.75. If you're still awake, I know a couple people have dropped off, but I'm done fighting with anyone about that. So if you're still awake and listening, here it goes. If you round this up, then you would make a mistake and say the answer is 24. It's not okay to round up in this case. What happens if I do 24 weeks? I passed it, didn't I? It would be really easy for me just to go, ooh, 0.75 is bigger than 0.5. And my teacher in 5th grade taught me that if it's bigger than 0.5, I round up. You can't do it in this case because it's a real worldy kind of problem. If I go up to 24 weeks, I have gone and crashed down through that wall in my account and I'm going to get the fee, right? So no matter how close it gets to 24, I can't round up in this case. I have to say 23. Got it? Does that make sense? You don't always round according to the rules of math. Sometimes you round according to the rules of common sense. It's weeks, because remember, we're pulling out money $20 per week. So if I went 23 weeks and I pulled out $20 every week, I would still be above $10. If I went to the 24th week and pulled out 20, I go boop, and I drop below 10 and they hit me with the fee. So part B on this question, I told you this was a 3-part question. All of what we just did was part A. Part B is the graph. And so we're simply going to make a graph of x is less than or equal to 23. Color in the circle, shade to the left. And you know what? I actually probably shouldn't put an arrow, should I? Because can you go negative in time? No. So really, I think what I would do in this case is I would go and I would make a number line and I would have it stop at 0. Would you agree with that? That I really shouldn't have an arrow because the arrow indicates that I can go and, ooh, if I go negative 10 weeks, like, that doesn't make sense. So you can go basically and say anywhere from 0 to 23 would be just fine. And then the last part, and then I'll get you out of here, is to write a complete sentence. This is part C. And again, I know there'll be some of you that despise this, so I'm just telling you that I'm aware of that. That the last part is you have to write a complete sentence to answer the actual question. So you could say something like, I could withdraw $20 for up to 23 weeks without going below the limit or something like that. Nice complete sentence with subjects and objects and verbs and all that stuff, capitalization, punctuation. So, any questions? That cut it a lot closer than I meant to. You guys have 51 seconds before the bell. So, you want to wait and do this later this week? Which, how about this? I'll go ahead and throw the DA on Thursday, and that'll give anyone who has questions some time to get in and go over anything. It's all on the recording. You guys good with Wednesday?
Sure.
Oh my God. Wednesday it is. Wednesday, district assessment Wednesday. Wednesday.